Okay, we're going to start lesson 9.7. So 9.7, put that at the top of your paper. And this lesson is on congruent and similar figures. Now, congruent means identical or the same. So they have the same two shapes that have the same size and same shape. So for example, if we have two triangles, they are both the same size and the same shape, those are congruent, which means they're exactly the same. Now similar is a little bit different. And we're talking about the same shape but different size. So if we had two triangles, the same shape of a triangle but a different size of a triangle, those would be similar. And then our third word that we're going to put down is corresponding. And when we talk about corresponding parts in math, we're talking about matching. We want to match the sides and we want to match the angles. So we want the matching sides and matching angles. We're going to start our lesson today on page 456. So 456. And we'll start with number 1. We're going to tell whether the statement is true or false. And our first statement is a triangle VUW is congruent or identical to triangle XYZ. So we have those two triangles. One is a little bit larger, one is a little bit smaller. And we are saying they're congruent because they have the same size and same shape, which is false, because they do have the same shape, but they have a different size. They're different sizes. So we're going to say that this statement is false, and the reason why it's false is because they're not the same size. Skip a line, go to number 2. We are going to take a look at those two triangles again, and the statement says triangle VUW is similar to triangle YXZ. And that is true because they are the same size, or same shape, excuse me. They're the same shape, but they are a different size. So same shape but different size. Skip a line, go down to number 3. We want the two shapes are congruent. This is the algebra portion, and we want to find the value of x and y. So here we have two different shapes, and you can kind of sketch them out, and they are 10 meters by 10 meters by 4 meters by 4 meters. And then we have the second one. Now they just kind of rotated it. Same shape, same drawing, kind of rotated. 4 meters, 4 meters, 10 meters, and we have x. And we want to know what is the value of x, and y. So this one here down here is y. So we say, okay, well, if these are both the same, if they're both congruent figures, then both sides are going to be 10 meters. This seems kind of rather obvious, but x is equal to, of course, to 10 meters. And y is equal, of course, to 4 meters. And box those in. Number 4, if we take a look at those true triangles, we want to find the value of x and we want to find the value of y. And both of these triangles are congruent, which means they're the same size, same shape. So if they are the same size and same shape, then the value of x down at the bottom must be equal to 4 yards. And if they're the same, the value of y must be equal to 5 yards. And make sure you box that in. Number 5, we have actually I think I skipped one. So actually this is number 5, or 5, and this was number 4. I skipped number 3, so I'm going to put that down here. Skip number 3. So in figures V and line segment VW, it corresponds to line segment YX. VW goes from an acute angle to an acute angle. YX goes from an acute angle to a right angle. So if we say that those are, or they correspond or match, the statement is equal to false. That's not true. Okay? They don't match up. They don't lead in the same direction. Let's go to number 6. Number 6, we want to tell whether the triangles are similar, congruent, or neither. If we take a look at those two triangles, one is larger than the other. They are a right triangle. All the angles are different sizes. So, but they are the same, other than the fact that they're not the same size. So we would say that those two triangles are similar. Number 7, we take a look at those two triangles. And even though they're not situated the same way, they're turned or flipped, we can see that we have two triangles that are the same size, they're the same shape, they have 3 different angles. So same size, same shape means congruent. And make sure you spell that correctly. Number 8, we take a look at those two triangles, and at first glance they look like they are the same. But if we like to take a look at the measurements, we have the triangle on the top is 10 inches on one side and 8 inches on the other side. So that's going to change the angles a little bit as well. So these two triangles, even though at first glance they look like they are the same, they're not the same size. And they're not the same shape either. So in this case, they're neither. Skip a line, go down. The next part is to use the corresponding part, list the corresponding parts. Now for this one you're going to draw these two triangles best that you can. This is a right triangle. So we're going to copy these down so we have these right close by. And the top two angles are a different measurement than the bottom acute angle. And we're going to label these like they are in the book. Angle A, B, and C. And angle D, F, and E. Now this is extremely important to get this to match these up. We want to find the corresponding or matching parts. So in this case, the two right angles, we can say that angle C corresponds to angle F. So angle C and angle, I should put the word and in there, angle F, they correspond. Angle B and angle E correspond together, match. Angle A and angle D match. And again, they're marked the same way as well. Now the corresponding line segments, we have to match those up as well. So if we go from the right angle, angle C to angle A, we want to go, so line segment CA, this side here, we want to go the same direction on the second triangle, so FD, and it has to be, you can put a little and symbol there, so that corresponds, CA corresponds or matches line segment FD. And then we could say that line segment CB, in all caps by the way, line segment CB matches line segment FE. And again, they have to be in that order. And the last line segment is from A down to B, or D down to E. So we could say line segment AB matches line segment DE. Now we could change these around. We could say, if we said line segment BA, we could say that that matches line segment ED. We could switch those two around. So if we went BA, we could switch that around with ED. But we have to switch both of them around. So those would be both the same. And of course that would follow the same with the, if we went from CB, we could go from BC, and then we could go from E to F, line segment E to F. Those would match. And of course if we went to the last two, we'd have, instead of CA, we could, so going from the right angle to the acute angle, we could go from A to C, line segment AC, to line segment D to F, in that manner. So we'll do another one like that in just a moment. So that's number 9, but there are 3 sets of matching angles and 3 sets of matching line segments. So there's 6 parts of that, finding the corresponding parts. Number 10, we're going to copy this one down as well. We are going to have copy down triangle H, and this one's marked with 2 little arches, and then G and J, G and J. And the other one, triangle MLK, is just flipped up. So we're going to just flip it down, and we're going to flip it down. So this, the top part is going to be L. And if we just flip it down, then this is going to be M. It's going to stay on the same side. And angle K is going to be over here. And we're going to do that so that we don't get them mixed up. We want to kind of position them side by side so that we can match them up the best way possible. Then it becomes a lot easier to match them up. So we have H and L, obviously. Angle H and angle L, they correspond to each other. Angle G and angle M correspond or match to each other. Again, the angle symbol. Angle J and angle K match or correspond to each other. Now those are the matching angles. Now we want to match up the matching line segments. So starting from the top, we could say that line segment HG matches with line segment LM. And then we could say that line segment, that's one side, that's this side. And then we could say that line segment HJ matches up with line segment LK. That's those two sides. In the base, we could say that line segment GJ matches up with line segment MK. And they match up with each other. So we have 3 sets of, in this case, because it's a triangle, 3 sets of matching angles and 3 sets of matching line segments. Now, if these were quadrilaterals, there'd be 4 sets, but that's for now. Number 11, we want to, these 2 figures are congruent, which means they're identical. We want to find the values of x and y. So if we take a look at number 11, they're congruent. So we know that there is a right angle in this one. So we want to say that we don't know the measurements, but we know we're missing the right angle there. So we know that x is going to be equal to 90 degrees. And y is the side on the top. So if we turned it, what would be the length of y if it matches up to the second triangle? And if you said 13 feet, you are exactly correct. Number 12, I'm going to put it right down at the bottom of the page here. Number 12, we want to find the value of x and y. So if we take a look at x, x is the angle, it's an acute angle.